Hi, everybody. My name is Ben Bleything. My pronouns are he, him. I'm here to talk to you today about what I think is absolutely the most exciting aspect of modern application development, which is background processing. Thank you. And I want to talk also about serverless and how you can kind of put the two together and do interesting stuff. A little bit about me. I'm Bleything everywhere on the internet. I've been doing Ruby for a long time, almost 15 years. I've worked on some pretty interesting applications like GitHub and Living Social, White Pages, and then some others in smaller, more interesting but less startup-y places like animation and financial services and indie music licensing. And I've seen some stuff, as it says. My focus is mostly on infrastructure and operations and architecture. And I am a developer advocate at Google now, and my job there is to think about those things and to think about how to modernize our architectures, modernize our systems, how to make them better for both for us as developers and for our users by adopting new technologies, which I don't necessarily mean new like emerging, but new like new to us. And just kind of think about how to make things better. So that's what I want to talk about. Before I go on, though, I want to make a couple of disclaimers or whatever. First of all, this is not a sales pitch. I am not here to try to convince you to use anything. I'm not here to try and convince you that serverless is the way to go. I'm not sure it's the way to go. It might be for you, might not be for you, I don't know. I'm also not here to tell you to use GCP. You can, and if you're using it, awesome, that's cool. If you don't have a cloud provider yet and you're looking for one, check us out. It's pretty neat. But I'm not interested in trying to convince you to come use my thing if you're already using something else. The truth is you probably don't need this stuff. I don't think anybody needs it. I think it's cool. I think there's a lot of interesting ideas here. And I think that those ideas are inspirational. I think that we may find as we explore this, and I don't mean during my talk, but I mean as a community, as we explore this over the coming years, we may find a lot of interesting places where we can use these technologies to make our stuff better. And like I said, I'm not here to tell you you should do things. You're the only people who know enough about your systems to know whether or not the things that I'm going to talk about are the right fit for you. My hope is that I can tell you about some of the things that I found out as I was researching this talk, tell you about some of the things I've learned, and maybe inspire you to go do some experimentation on your own, and maybe save you some time, because there are some caveats that I'll go over as we get into it. So, with that kind of introductory material out of the way, let's talk about background processing. I suspect that most folks are familiar with this. This is when you have something that you're trying to do, and you want to get it out of the request cycle because it takes too long, and you're either going to send a timeout to your user or just make a bad experience. An example I'll use later is like you're building the new YouTube, and you want people to upload videos, but you don't want them to sit there for however long it takes to transcode those videos. Oh, sorry, I forgot to mention, I developed a cough this morning, and so I'm going to be hitting the water quite a lot and potentially turning around and turning off my mic and coughing a little bit. I apologize. I don't like it either. Anyway. Sorry. Oh, yeah. So with background processing, probably most folks have either seen or worked with Sidekick or Rescue or something like that. There are others out there, Delayed Job and Sneakers, Backburner, Sucker Punch, a bunch of others. This is a really common thing in modern application development. There's a lot of times when you want to offload some work and do it in the background. So just out of curiosity, how many folks have used something like that before? Yeah, okay, that's what I thought, it's everybody. Who's built their own? Cool, All right, sort of. All right. Is anybody using what they would consider serverless right now for background processing? Sweet. I would like to talk to all of you later. And probably you're going to want to talk to me too, because I'm sure I'm going to say some stupid stuff, and I would like for you to correct me. So what is serverless? I went into this having a really vague idea. I've been around this world for a while, as I mentioned, but serverless is just one of those things that I've never had to touch. And I was always kind of curious what it meant. And I had built this, over the years of being just around technology, I had built this internal definition, but I wanted to see how it matched with the other people on the internet who think about this stuff more than I do. And so I asked my friends, what's your internal tweet-sized definition of serverless? And I got some interesting answers. The first one I got is from Jason Watkins, who's a Rubyist, old-time Rubyist out of Portland. He said, function as a service works fine for me. And I suspect for most people, that's probably the case. Like, serverless, when most people think of serverless, most people think of functions. It's kind of I believe, one of the oldest things that ever called itself serverless. And it's still probably one of the most used. There are other things, and I'll talk about them in a few minutes. But for the most part, I'm going to focus on functions because it's the most accessible and I think the easiest to understand. Aja, who some of you know, said, pay per unit compute. You pay some tiny amount each time you use compute, and then you don't pay when nothing's computing. So at Google, we talk about this in terms of scale to zero. I don't know if that's an industry standard term or if that's just a term that we like to use. You might consider it pay as you go or whatever. To me, this is interesting stuff because this has the potential to be a revolution in the way that we think about cloud, like compute resources, in the same way that EC2 and cloud VMs were, 14 years ago. So before that, and by before that, I mean before you adopt the cloud, when you're still running your own metal, you have to buy capacity months in advance. About a year and a half ago, I was still a consultant, and I put in a $250,000 order for new servers for one of my clients. And we had to wait almost 9 months to get them because there was a worldwide flash shortage going on. And we just couldn't get SSDs. Dell couldn't get SSDs, or well, rather, Dell wouldn't sell those SSDs to us because they were selling them to other people. And so we had to wait forever to get those. So we had to plan, at that point, we were planning over a year out for that additional capacity because we knew that we were gonna need it in a year and that it was gonna take us 9 months to get it. And then, of course, another 3 months to get it burnt in and set up. When EC2 came on the scene in 2006-ish, it kind of changed all this because now you can buy compute right now. You can buy it in a matter of seconds or minutes rather than in a matter of weeks or months. I know this is not new information, but I mention it because to me, serverless is the next jump of this. Instead of paying for capacity, now you're paying just for usage. With VMs, you are still buying capacity. You're still saying, I want some number of CPUs, some amount of RAM, some amount of disk, some amount of network, and just let it sit there until I need it. And then when I need it, I'll use it. And then when I don't need it anymore, I'll either stop using it or I'll turn it off, and then I'll stop paying for it. But serverless is the next step. Serverless says, OK, cool. If I'm not using it, don't charge me for it. Like, here's something. Please run this code when somebody wants to interact with it. If no one's interacting with it, don't charge me for it. So the shift from having to buy this capacity months in advance and doing, by the way, if you've never been part of a capacity planning exercise for like actual physical hardware, find someone who has and talk to them about it. Ask for the stories. It is wild, and I think it's something that people who are not in operations don't think a lot about and maybe haven't experienced, but imagine having to predict not only the growth of your user base and the growth of the way that your users are going to be using your system, but also new features, new developments, new technologies over the course of 15 months. Trying to plan out that far in advance so that you can buy the right hardware now to have it when you need it. It's very, very difficult. Yeah, highly recommend asking some people who have been through it. It's crazy. So, but serverless lets you kind of ignore that. It's just like, hey, I've got more demand today. Please execute some more times. My coworker Sandeep had another take. He said, anything that charges only by usage and requires no manual scaling or provisioning. So the first part, that's kind of what we were talking about before. But the second part is more interesting, no manual scaling or provisioning. So we have auto-scaling. We've had auto-scaling for a long time at the instance level, like the VM level. And we've also had it in Kubernetes for containers and things like that. So this is not necessarily like new and revolutionary, but it is still interesting. Because now, again, you have this code sitting there somewhere, and I'll talk more about it, but like you've got this code sitting there, and if no one's using it, it's fine. And if then 1 million people are using it, 1 million people can use it at the same time. And you didn't have to do anything, it just happens. And same thing with provisioning. You don't have to worry about VMs, you don't have to worry about setting up your network, you don't have to worry about configuring any of that stuff. You're just like, here's some code, please run it. Obviously, I'm doing some hand waving. You do have to worry about some of those things, not all of them. But you know, this is the sales pitchiest part of this whole thing. I know I said I wasn't gonna be, but yeah. My friend Jack went into just a little bit more detail about this. He said, serverless heavily implies a near zero ops workload. No Chef, no Terraform, no Dockerfile, et cetera. And I kind of get what he's talking about. I think from the developer's perspective, this is true. You get to stop thinking about a bunch of stuff that you had been thinking about. You don't have to think anymore about, you know, like the whole Rails framework. Now you're just focusing on a little bit of code that just does the thing you're talking about. But as I said, I come from the ops world, an ops background, so I know that like we're not really getting rid of ops responsibilities. We're just shoving them somewhere else. But if you're buying your serverless stuff from a cloud provider, you're shoving it off to the cloud provider. Your ops team doesn't have to worry about the operations of the function, like the function framework or whatever anymore, because you're paying your cloud provider to think of it for you. So these things get shifted around, and some of them you can stop paying attention to, and some of them you think about differently. But this is another big point. Another big point of serverless is that it reduces your overhead, and overall, I think it does. So just quick, functions as a service. I've mentioned it a couple of times. The idea is you take the small chunk of code, a function in like the CS, like the programming language sense, and you shove it up in some framework somewhere, and that framework handles getting requests to it. And that can happen in several ways. One of those ways is via HTTP. One of those ways is via message queue. Every cloud provider also offers the ability to like respond to events that happen elsewhere in their infrastructure. And I'll talk about all these with some fairly contrived examples in a second. But I want to say just one thing real quick. If you haven't already looked into this, before we go too much farther, I just want to warn you that if you want to do Ruby, if you want to write functions as a service in Ruby, you have to use Lambda, AWS Lambda. Google doesn't support it, Azure doesn't support Ruby, Amazon does. I don't know about IBM Cloud, I don't know about Oracle. They might, but I can tell you for sure Azure and Google don't. So this is something that you have to be aware of, that this stuff all sounds super cool, but Ruby support is not as strong as it is in other places. So anyway, just with that out of the way. Let's take a look at one of those really dumb contrived examples I just mentioned. So a webhook handler. Say for some reason you've decided it's a super cool idea to write a custom continuous integration, continuous delivery tool. So you want to take GitHub webhooks and you want to build artifacts when those webhooks come in. So in the super basic sense, it might look like this. You have GitHub, it's sending you a webhook, your Rails application is catching that webhook, and then it's enqueuing a job in Sidekick. I'm gonna use Sidekick as a stand-in for background processing in general, just because it's what I have used almost exclusively, and it's what I know, but feel free to replace the Sidekick logo with your background job server of choice. So if you want to serverless it up, you can use the HTTP method that we talked about before. So at Amazon, they have this thing called API Gateway. And it is pretty much what it says, it's an API gateway. It takes those HTTP requests and it translates them and sends them over to the functions running on Lambda. I don't know, and I would love to know if anybody has a better answer for this. I'd love to hear about it later. I think we call that idea an API gateway because Amazon calls theirs API gateway, and that's just what happened. It may be the other way around, I'm not sure. But this is interesting. This method of invocation is interesting for several reasons. One of them is what we were looking at a second ago, which is this webhook idea. I didn't mean to go back there, I'm sorry. I meant to go forward. This webhook idea, where webhooks are fairly standardized now. A lot of services will send you a hook. And if you can consume that hook directly without having to run your own Rails application or Sinatra app or whatever, if you can just throw it right at a function, then you've got this, all of a sudden you have this much smaller piece of code to maintain that does the same kind of work. It's also interesting because HTTP is absolutely, without question, the standard, like, de facto transport of our industry. Everybody knows how to use it. Everybody works with it every day. It's what we know. It's very well understood. There's good tooling. And so this is kind of a very low barrier to entry way to get into functions, is you just put a gateway in front of it, or if you're using Google, I think we don't have like an API gateway thing. You just say, expose this to the internet, it takes care of it automatically. I think Azure works the same way. But it's effectively the same. It's putting something like that there, it's just managed for you. Okay, cool, but like, why would you do this? Like, what's the point? And in this particular case, that's a good question. It's hard to say. Definitely, this has simplified your environment a little bit. Like I said, now you're not running a Rails application or Sinatra or whatever anymore. Now you're just running what is effectively the action that does the thing. And like, okay, cool, that's kind of neat, whatever. It also separates it from your production infrastructure if that's something that's important to you. If you want it to be running on a completely isolated set of compute that's so far away from what you're doing, sometimes that's important. If it seems like I'm having a hard time coming up with stuff, it's because I am. This is kind of neat, but I'm not sure it's super compelling unless you have a compelling use case for it. But the contrived example, not a compelling use case. I had another point and I've lost it, I'm sorry. So let's look at another example. Text processing, another common use case for background processing in a Rails app, or a web application, or any kind of application. Imagine you're making a new social network. You're tired of Twitter, it's time for something new. But you've been around for a while, you know you've got to do some stuff. You have to, people are gonna post their, whatever you're gonna call them, their status updates. And you're gonna have to index those, like you have to be able to search them. You probably wanna do some spam filtering. You probably wanna do some analytics. You wanna look for links. You wanna figure out who's talking to who. You wanna do all of these things. Like this is common text processing stuff. So again, this is the very simple case. You have your clients, they're talking to the Rails application directly. You're doing that stuff right when you get that status update. You're doing it inside the request cycle and you're throwing it in the database. This is how we did things a million years ago. And in small, for low usage, small, simple tasks, you could probably still do it and get away with it. You'll be fine. Then you start to grow and you want to search better. Like you could search in your database or you could use something like Elasticsearch. You decided to use Elasticsearch because I couldn't think of another search engine tool besides Elasticsearch. So that's the one we're using. And so all you really do now is instead of putting it just in the database, now you're putting it in the database and Elasticsearch. And again, if you're still relatively small, if it's pretty simple, you might still be able to do this synchronously. You might still be able to do it as part of the request cycle, and it might not be that bad. But there will come a point when it will be that bad, and you won't want to do that anymore. And so you're going to go to background processing. So again, I know that this is not interesting or new information. Rails app goes to the background processing. It can pull the information out of the database, process it, put it back in the database, put it in Elasticsearch, whatever it needs to do. And that's cool for a lot of reasons. Mostly, it speeds up your requests and all that, but it also allows you to parallelize this so you can do a lot more at the same time. Thank you. I was not sure about that joke, so thank you. Okay, cool. So that's all fine and good. How would you do this serverlessly? Well, one way is to use that message queuing stuff that I was talking about earlier, the message queue style of function invocation. So in this case, you have that thing that looks like an iMac is actually a Rails application in this case. I'm sorry, I used the wrong icon. So it's putting a message into the message queue, and then that message queue is forwarding that message on to any functions that have said, hey, I want to know about this kind of message. So for our Rails app that we were talking about, our new social network thing, here's kind of what that could look like. Is you get that message into the Rails app, then you send it to the database, then you drop it into the message queue. At Google, we call ours PubSub. and then it passes that off to every function that has said, yo, I'm interested in messages. So you got your spam filter and indexer and the analytics analyzer, or whatever you want to call it. And this is a pretty simple, straightforward kind of thing. So why would you want to do this? Well, scalability is a good one. Say, you all of a sudden you have 10 million new users, and all of a sudden your search indexing went from taking, a millisecond or 2 milliseconds per post to now it's taking 100 milliseconds, and you're not really sure why, and you're trying to figure it out. Well, that's going to really slow down your queue. You're going to end up with this big backlog. And you can fix that by scaling up. You can, add more workers or whatever. But if in this kind of serverless world, that scale up happens for you, it just kind of is there. And all of a sudden, you have more traffic, it's doing more work for you. It also lets you decouple, again, your processing code from the rest of the application, which may or may not be of value to you. One place where it might be kind of interesting is in the case of like having a diverse tech stack. So say your main application is written in Rails, but you're doing a lot of ML work with the text of the status updates. Python is the de facto language for ML. And so maybe you want to do a bunch of processing that's in Python. You can do that here. You just write a Python function instead of a Ruby function. And in fact, if you're on Google, that's your only choice because we don't support Ruby. Of course, there are also disadvantages. It's pretty opaque. You don't necessarily have the level of insight into that message queue as you do into your own Redis or Rescue. Your own Sidekick kind of thing. It's also complex in the sense that there are more moving parts. Now you have these functions elsewhere that are not necessarily in your Rails app. They could be, you could store the code in the same repo, but it's another piece moving somewhere else that's managed in a way that you don't necessarily know a lot about, that you're still responsible for monitoring it, and you're still responsible for making sure it all works. The other thing that I wanted to mention is this is what we were looking at a second ago, and the keen observer will notice that this is exactly the same as doing it with Sidekick. There is no real difference between putting it in PubSub and fanning it out to a bunch of different functions as there is putting it into a background task executor multiple times to do different kinds of things. There are some small differences in the way that you would actually write that code, but this is not a wildly different way of thinking about it, which, that could actually be good. This makes it a little bit easier to adopt this style because it's a more familiar flow of stuff through your system. Yeah, but why? Maybe you don't want to run a background task executor. Maybe you have limited resources and you don't want to spend any of those resources on keeping servers running just to run background jobs when they're available. Again, I know I've said that 4 or 5 times in different ways already, but maybe, that's actually a reason why you might want to do this. Another interesting reason is that on the major cloud providers, there are lots of services that can consume from those PubSub or message queues. Excuse me. So for instance, I mentioned ML a second ago. Maybe you want to use one of the providers' managed ML stuff. You can just point it at that queue, the queue that already exists, that you're already using for all of your other stuff, and it will start consuming that too. Maybe you want to put all that stuff into BigQuery, for instance, is our big database thing. And you can just point it at that queue, and it will start consuming that stuff. So it gives you a way to integrate with managed services, the managed services that your cloud provider provides in an interesting way. So that's another kind of interesting thing. And then also, it's serverless, and so serverless is cool. Let's talk about another one. I mentioned new YouTube, so let's look at that. So in the very simple case, again, you're uploading a file to the Rails application, then that Rails application is going and putting it on an object store somewhere. Maybe that's its local disk, but much more likely it's something like S3, Azure Blob Storage, or Google Cloud Storage. And maybe it's doing a little metadata extraction while it's at it. And if you're using active storage, or Shrine or Paperclip or anything like that, this is probably, in the default state, this is basically what's happening. file goes to your Rails application or to your web server, and then it gets put up wherever it's ultimately going to live, and you can attach some hooks to do other things like metadata extraction or whatever. But what do you do when you want to do more things? Say you want to like transcode that video to a known good format or a format that works better for mobile or whatever else, just transcode it. You want to do that. You want to still do the upload. You still want to extract the metadata. So again, background task makes sense here. And in fact, maybe depending on which of the, which file upload management tool you're using, it might actually do this for you. It might actually have those jobs built into it and queue those jobs for you. Again, this is a very typical like media management, audio files, photos, movies. It's all, this is pretty standard stuff. And just for what it's worth, the flow of jobs in this is not exactly, what I showed before. After you transcode, you do need to upload whatever the result of the transcode is. You have to upload that too. So that's going to fire off another job. And maybe you're going to want to add a second format or whatever, upload the original, all that stuff. So how do you do that serverless style? Lots of ways. You could just do the message passing thing like we were talking about a second ago with the message queue. Or you could look into the service event invocation style. So this is the one where something happens somewhere in the cloud, and it tells your function that that happened, and you react to it. So in this case, again, this is Google Cloud Storage. When you upload a file, it will tell your functions, hey, this file just got uploaded. Would you like to do anything about that? And if your functions have said, hey, I'm interested in this kind of event, they will get invoked and fire and do their thing when that file gets uploaded. Every time a file gets uploaded to that bucket or whatever they're called, it'll trigger that function. There are lots of different events available. Every service provider has a different set of services that this works with. So look into it if this sounds interesting. On Google, on GCP, we offer events from storage, like I said. Also events from our Firestore database and from some of the Firebase tools like authentication and analytics. If you look at Amazon, they have exactly the same thing with storage with S3, but they also have events from Alexa and some of their, I think it's called Lex, is like a chatbot kind of service, like a human interaction service, and there's some others. So there's lots of services available that can trigger these functions. So back to our thing, so your Rails application is uploading that video to cloud storage, and then when that upload is finished, it says, okay, cool. That object, we call it object finalized. It probably has a different terminology other places, but that message gets sent over, and then every function that said, hey, I'm interested in finalized objects gets invoked. And so we're going to transcode it. The transcode's going to upload it back to storage. The metadata extractor is going to do its thing. And then, eventually we'll notify the user. You probably wouldn't actually design your system this way, where probably once you transcode, you're going to put it into a different bucket. But if you did put it back into that same bucket, what would happen is you'd get another message about it. And so you could very easily get into this loop where you're just transcoding the same video forever. And so this is one of those things that you have to be careful of. If you're using this style, you just have to be careful to make sure that you're not executing jobs that you're not supposed to be, that you've already, you're not redoing work that you've already done. So in this case, you might make that job take a look at the metadata of the object or where that object is inside the bucket and say, oh, this looks like something I already transcoded, I'm just going to ignore it. Or like the notifier might only notify once it sees a transcoded image, or a transcoded video. It might, when it gets the original raw video, it's not going to do anything, but when it gets the transcode one, and that object has been finalized and uploaded, it'd be like, cool, now I can tell the user. But yeah, you should definitely just use separate buckets if you're building YouTube. Okay, why? Why would you do this? This is kind of an interesting one. So video transcoding is a very intensive process. And because it's a very intensive process, you might not want to have the capacity inside your data center or inside your cloud account to handle the load that you're going to have at all times. So again, we're talking about scalability. Although I should also say that because it's an intensive process, it's not necessarily a great fit for running on cloud functions, but I'll talk more about that in a second. But if you think about other things, image processing maybe versus video processing or audio or scanning PDFs or something like that, these are still good options and they do allow you that flexibility. And again, like I said on the previous example, the ability to choose different technology if something makes more sense for you. If you have something that performs better than what you could do in Ruby, you could potentially do it in that, assuming your provider supports that. Downsides, pretty much the same as before. It's more opaque. In some ways, it's even more opaque than before because now, at least when you're using the like SQS or PubSub or Azure Queue, you can interrogate that queue and say, hey, how many messages do you have? What am I waiting for? What's going on here? When you're just waiting for something, S3 to tell you to do something, you can't necessarily, there's no way for you to find that out. So you have to pay a little bit more attention, and your monitoring situation is a little bit different than what it would have been otherwise. But the thing is, you're going to be monitoring it one way or the other. So it's not like it's new work that you have to do. It's just different. There's more moving pieces. Now, in addition, to your actual job executor thingy, which is in this case is the function, you've got that queue that you don't have any access to. And you have whatever fan out might be happening that you don't really know anything about. And then storage is another piece. So there's a lot of pieces that are moving here. So again, this is a way that you could do it, but it's not necessarily a way that you should. It's really up to you whether or not this fits well with your application. So I want to leave you with a few things to know. Some, I guess you could sort of call these warnings. I've talked a lot about scaling, automatic scaling, but it's not unbounded. Like all of the providers that I've seen have a upper bound to how far they're going to scale for you. And you actually want this, because what you don't want is someone to maliciously upload several million terabytes several million videos, several terabytes worth of videos, and all of a sudden your bill is $6 million, because it's just like, okay, cool, well, I'll just do all these at the same time. And the cloud providers are going to try and save you from that a little bit by putting some limits in place. There are rate limits, there are execution limits, both simultaneous execution limits and duration of execution limits. There are resource limits, like you can only use so much RAM, you can only use so much disk. And you have to know about all of these, you have to think about all of them. I did an experiment a couple of weeks ago where I put 100 million messages into Google PubSub and consumed them with Cloud Functions as fast as I could. And it turned out that as fast as I could was around 5,000 a second, which, I mean, 5,000 a second, that's a lot of messages. That's pretty good. But I've worked on systems that needed more throughput than that. I would imagine there's lots of people in this room who have as well. And so this is something that you need to think about. You need to understand the limitations of the system, and because this is a limit with Google anyway that cannot be changed. So that is a hard limit that you cannot go over under any circumstances. So if you need more throughput than that, you need to re-architect your system, do it a little bit different. You also really have to understand the systems involved, the pieces that you're using. So part of that is understanding the limits, like I was talking about, but part of it is understanding the semantics of those systems. So again, for instance, that experiment that I did, the 100 million messages in PubSub. The thing about the PubSub, the message queue products at the major cloud providers is that by default, none of them guarantee that you're only going to get a message once. They all do at least once delivery, and none of them guarantee ordering. You can turn those features on in various ways. At Amazon, you could just create a different kind of queue. I think that's the same at Azure. With Google, you have to pass it through our data flow product, through a particular workflow that orders and deduplicates the messages. But this is something that you have to think about. Out of that 100 million messages, I got about 0.1% repeat messages over the course of 24 hours. So about I think it was like 110,000 messages repeated. So if I was sending emails, that would not be acceptable because I'd have 100,000 people who got multiple emails. And when I actually did a further analysis of that, a lot of those messages were the same messages that were just delivered tens of thousands of times. And so you could end up in a situation where you see a very low repeat message rate. Say you've sent 100 million messages and you only see 10,000 messages repeated, but it was one message 10,000 times, and now you've got a very pissed off user. So you have to think about these things and be careful with them. Sometimes it doesn't matter. If you're indexing text, if you're just shoving it into Elasticsearch, you don't care if you do it twice. It's fine. It's the same text both times. It's not going to do anything the second time. That's fine. In that case, it's fine. Email, maybe not so much. Email, you want to have a little bit more structure around it so you're a little bit safer. And then you still, like I said, you still need to monitor everything. You still need to build tools and build systems to monitor what's going on, to make sure that you're doing all the work that you meant to do, that it's getting done in a reasonable amount of time, and that it's getting done correctly. And hopefully, the ecosystem will start to provide some of those tools for us. Some of them may already exist. If they do, I don't know about them, and I'd love to hear about them if you do. But that's just another thing to think about. So if you want to go do some more digging, these are, you could just Google, AWS Serverless, Azure Serverless, and GCP Serverless. These are the sort of like product landing pages that describe each of the three major providers' serverless offerings in general. If you want to dig a little bit deeper into functions in general, you want to look at, on the left, we have the products, Amazon's Lambda, Azure Functions, and Google Cloud Functions. On the right are some open source projects that do the same thing. OpenWhisk, this is an Apache project. It was, I don't know how tightly, I think it might have been created by IBM. It certainly powers IBM Cloud's cloud functions. So it was either created in partnership or by IBM, but it's an Apache project. FN is the same kind of thing, but from Oracle. I don't know if it operates Oracle Cloud's functions or not. If you do know, I'd love to know. But it's a project that they sponsor. And then Fission.io is just one of several frameworks that put functions as a service on top of Kubernetes. So Fission.io is one. There's one called OpenFaaS, and there are certainly others. And that's all I've got. Thank you so much for coming. Like I said, I'm Bleything everywhere. You can find me GitHub and Twitter. Bleything.net is my website. You can email me and whatever, and I'd love to talk to you more. I'm going to be at the Google booth in the exhibition hall for the rest of the day. So please come by and say hi, and especially if you're doing this and want to tell me about how I was wrong, because I really would like to, I honestly, sincerely would like to know that. All right, thanks so much.